Hello everyone and welcome you all for this online video session on the topic advanced techniques for the prompt engineering. So in the earlier session we talked about what is prompt engineering. So after learning what is prompt engineering, let us try to expose this field called as different advanced techniques for the prompt engineering. Myself Dr. Vipul Kondekar from Walchand Institute of Technology, Solapur. So let us have knowledge about different advanced prompt engineering techniques. So these many advanced techniques are designed. So these techniques are designed with the aim that you want to get the improved performance, improved result, effective and efficient performance from the LLM model for different complex tasks. So here is the list of different prompt engineering techniques. It starts with a technique called as few shot prompts. Then there is a chain of thoughts prompting approach. Self consistency is one more approach, and then knowledge generation prompting, and at the end react. So these are the different prompt engineering techniques we will try to expose today. So few shot prompt. So let us try to understand what this few shot prompt is. So this, as name indicates, so this few shot prompt allows us to provide the different sample examples as a part of series of prompts, so that the model will understand and then you will get the better and better performance from the model. So what is done here is, you will find that there are some inputs and output relationships, or the input output statements are given as the input prompt itself. Like if you look at the odd number in the group add up to an even number, numbers are given. So numbers are 4, 8, 9, 15, 12, 2, 1. So if you look at which are the odd numbers, 9, 15 and 1. So if you add that 9 plus 15, 24, 24 plus 1, 25. Okay, so now if the 25 is the result, so whether it is a even number, 25 is even number? No. So I am giving the answer also expected as a input prompt instruction. So here the answer should be, the answer is false. So like that another series is given, you get the answer. Like that another series is given, you get the answer. And then at the end you ask the LLM model with some different numbers, that the numbers are like 15, 32, 5, 13, 82, 7, 1. And the model will learn from these few short input prompts given earlier. Because here if you look at the number, I want to add the odd number, so that will be 15 added with 5, result will be 20, added with 13, result will be 33, added with 7, 40 will be the result, and then added 1 to it, so 41 will be the result. Whether 41 is let us check again, this 15 plus 5, 20, 20 plus 13, 33, 33 plus 7, 7, so that will be 40, 40 plus 1, so the result is 41. So here, so if you give the prompt and the answer is add up to an even number, and then here the result what you are getting is the answer is true. Okay, so I think some number is missing here, but the result definitely is even number of, because of that adding missing number, and then that's why what answer you are getting from the LLM model is the answer is true. Now another approach is this chain of thought prompting. So here in this chain of thought prompting approach, what is done is the approach to answer this particular problem will be given as the prompt. So, prompting can be improved by giving the instructions about what is the task and what should be the steps you what steps you should perform to complete that task. So, it's like you have to combine it with the few short prompting so that you will get the better results. So, okay, so if the examples are not available, you may go with this zero shot COT also. So, if you look at this particular prompt, so the prompt is the numbers are given, and then the step by step procedure like adding all the odd numbers. Okay, so adding all numbers is giving me result as 25, and 25 is odd number, so hence the answer is false. Okay, and then later if you mention this procedure, what should be the approach to decide the answer, later you give some different number series, and then whatever odd numbers you add up, and then those numbers are added is giving you the result as 41, and 41 is not an even number, so hence the answer generated will be the answer is false. So this is called as chain of thought prompting, where the like human thought process, how you resolve a problem by performing different steps, so those things are given as a prompt. The approach to come up with the result, what steps you are following are given as the input, and later if you give some new number as an input, so it is giving you the very correct results. So like that, another prompt engineering technique is called as zero shot COT. So here in zero shot COT, it involves the adding the steps like think step by step to the original prompt. So here one statement is given, and then one question is asked. So I went to a market and brought 10 apples. I gave 2 apples to the neighbor and 2 apples to the repairman. So I then went and brought 5 more apples and ate one. How many apples did I remain with? And then the answer generated here is 11 apples. And then again let us think step by step. So here that response is generated like whatever stages are given in the given instruction, so are divided, okay, and step by step how the calculations were made, so those things are also coming as the result, because you first started with the 10 apples. In the statement you say I gave 2 apples to the neighbor, so what will be the status? You gave 2 apples to the neighbor and 2 to the repairman, so what will be the result? Intermediate result is 6, so that too is made available to you. So this is approach called as zero shot COT. So another thing is self consistency. So in self consistency, it is used to it aims to improve on the naive greedy decoding and use in chain of thought prompting. So here the idea is sample multiple diverse reasoning paths through the few short COT are given, and the generations to select most consistent answers. So definitely this helps to boost the performance of COT. So this prompt is given. So I was this prompt is been given. So I was 6 when my sister was half of my age. So now I am 70. So how old is my sister? So that answer is given here. So self consistency is another approach. Here the one prompt is given where the context is made clear with a series of questions and answers, and then you gave the procedure also, how you approach to solve that particular problem, and then if this consistent example problems and their answers are given as the input instruction itself, so again the same question if you ask, so now you are getting the correct result. So in the earlier approach you were getting some different result, so now you get this as the correct answer. So this is approach called as self consistency approach. So there can be a prompt where you are asking the LLM model to generate some knowledge. So this is how the different stages taking place when some prompt is given to generate the knowledge and how the answer is getting generated. So this block diagram just talks about how the answer is getting generated from the knowledge generation stage. Different knowledge parameters are stored and how it is integrated to come up with some efficient answer for the given question. So all it depends on how efficiently the prompt is given. So this is a general knowledge prompting example where some input is given, and then what knowledge you have in that input is also mentioned. Okay, so like that input and its corresponding knowledge is been given, and then once this input knowledge these combinations are given, later you ask, just as the input, one input is been given, that part of the golf is trying to get higher point total than others, and then you ask what knowledge you have in this, and then LLM model will come up with this answer. So the knowledge samples are used to generate this knowledge augmented questions to get the answers proposals. So the highest confidence response is selected as the final response, final answer. So these are the two answers generated, but the answer with this highest confidence prediction so will be given to you as the output for this prompt. So there can be program aided language models. So these are used as this program aided language models uses this LLM. So to read the problem statement and generate the program, and then not only just program but program with these intermediate reasoning steps. So this is this one example of this how you get the different responses based on the chain of thought model for the input, and then this program aided language model is given, and then you find that if you use this program aided language model, here you get this correct answer. So the last thing is this React. So this is basically a framework which is used to generate both this reasoning traces and this task specific actions. So this React allows to interact with these external tools. Okay, so that you can retrieve this additional information, and then whatever response you get you generate with this React will be more practical, more reliable and factual responses you will get. So this one example where it talks about the different results you get by using these two different approaches. So this is all about these different types of advanced prompt techniques. So hope you will remember the prompt which is given to the LLM model is important in deciding what response the LLM model produces. So thank you. So I wish you all the AI models, LLM models efficient utilization by giving efficient prompts to the model. So thank you.